Thank you so much for coming to this edition of Pydata Copenhagen. It's always nice to see so many familiar faces and so many new faces. So usually we do a quick raise of hands. Who is new here for the first time Pydata? Excellent. And just for fun, the old-timers? It's nice. We tend to get some 50-50. That's a very nice balance. So we are part of NumFocus. So NumFocus is an NGO, which basically is a financial supporter of all your Pydata tools. So Pydata tools include your pandas, your scikit-learns, your numpys, and a bunch of other stuff. So they are all financially supported by NumFocus, and Pydata is sort of the meetup/conference arm of NumFocus. Because of that, we also follow the Pydata Code of Conduct. This is the short version. I'm going to give you the slightly shorter version, but basically we make sure that we are kind to others. We do not insult or put down other people. We are professionals and we behave professionally. Racist, sexist, or any other kinds of harassing jokes are not considered acceptable at a Pydata event. If at any point in time you feel that you have been the subject of any of these, please do come find me. We will try to find a resolution. We have not had to use this at any point so far, so please don't make today the first time. So we have two practicals, the bathrooms. For those of you who haven't seen it, there are bathrooms right outside here, and there's one down and to the left. And the only other rule apart from the Code of Conduct is the Pac-Man rule. So as you may have noticed, there are a lot of old-timers and a lot of new people. We're here to socialize and get to know each other as a big part of the Pydata spirit. So to facilitate that, we have the Pac-Man rule. If you're standing in a circle and having a chat with someone you just met, it's very interesting, you tend to bunch up a bit together. It means that no one else can join your conversation. So try to remember to have one spot open for someone to join. And if someone does join, remember to open up again so that someone else can come join your conversation. That way we'll make it nice and easy for people to join your conversation if they hear something that sounds interesting to them. So that's the Pac-Man rule. We, of course, have to thank DFDS. This is usually where we would give them a second to talk, but they're going to do that a bit later. But we do give them a big hand of applause, please. So, of course, apart from hosting us in this lovely auditorium, they also paid for the pizza and the beers and the drinks. So we are very, very thankful to them for that. But you're going to learn a lot more about them in a little bit. We have our regular community announcements section, and this is for the community to tell everyone else about some job openings, some conferences, other meetups going on, something that you think might be interesting to other people in the Pydata community. Anyone have something they want to pitch today? Oh, I see someone, yeah?
Yes, I want to share we have positions open for data engineers here in DFDS. So we are in a silent journey of building a data platform and be more event-driven. Do more events-driven. So yeah, if you are interested, please switch to any of us.
Thank you very much. Anyone else? Going once, going twice? Cool, not so much today. We are available on Slack and LinkedIn, and of course on Meetup. So we have this code. I tried it a few days ago. It did work. Sometimes it doesn't. If it doesn't, find me, and I'll let you in. Of course, you can also search for Pydata Copenhagen on LinkedIn if you want to join that group. Please do come in. It's a nice place to ask some questions. Today's talk, we are fortunate enough to be joined by both Uriel and Per. And they're going to be talking about using OR tools for hazardous cargo planning optimization. So before that, I just want to have a quick one, because I always forget to say it at the end. We always need you guys. We're fortunate enough to have people here who spend their own time and invest and learn something new so they can come share with you guys. It's an investment, but it's also for you. So we're always looking for new speakers. If you're interested in speaking at one of these events, please do come find me. We'll find you a slot. We can always help you out massaging your talk or finding some interesting topic. So with that, I'll give the word over to Uriel.
Super. The presentation.
Oh, sorry, one more thing. I will be taking pictures throughout the event, so if anyone has any objections to being a picture, again, come find me. I'll make sure to replace you or don't use those pictures.
Then, move with this one? Or? Sorry. Yeah, you'll have to do that one. Cool.
Super. First of all, welcome.
Yeah, I don't think I will need a mic. I can speak loud enough. But then I want to introduce a little about DFDS, considering like most people only heard about DFDS because of the boat to Oslo. So yeah, I can see some nodding faces. But that's why it was actually interesting. That's the same I knew when I applied for this job. And I was not even from Copenhagen. Imagine that. But in reality, the company's been for like more than 150 years. And we are all around Europe. Our main business is supply chain and transport. So we have a lot of vessels that move things around, and that's what we're going to be connecting to what Per is going to be talking later. But we also have a whole logistic network that now we're even including on rail. So that's the kind of business we're doing, and we have like almost 11,000 employees, and we have like how many 35,000 voyages a year. So that's a lot, and that's what something that, as Per is going to show today, makes such a big dent and how it actually creates an impact. I will just showcase, because at least that's what interests me, how we are actually working on machine learning and inspire people to do the same, or if they want to talk to us. There's a big line of people also there working in DFDS, so you can also approach us if you have any idea or if you want to discuss more. But how do we use machine learning in DFDS? Our goal is to make DFDS more data-driven, and by that we mean using whatever we have the data to try to predict what is going to happen next, and that's our focus on machine learning, trying to learn those patterns, try to implement some kind of logic, and we can replicate it and create operational efficiencies by doing that. I'm going to spend like 1 second on each project, so don't worry if we go to the main event. But this is just some examples where we're using that kind of capability. We're doing a lot of marketing automation campaigns, so we're trying to understand what our customers might be more interested in upselling when they go to a cruise, trying to get them offers and trying to connect with them. We created a whole pricing engine for our whole logistics, trying to predict what are the costs and trying to identify and standardize what's the price we have to give them. We've been working as an airline industry at how much we have to overbook. And then we actually create models to say how many cancellations, and we need to identify how much we can overbook in order to reach full capacity. We are using image recognition in our gates. We have terminals, so we need to identify the unit numbers, the hazardous labels. That's something that has been going around the different terminals we've been using. We did a really interesting project about fuel optimization, trying to understand, in considering crossing, when do we have to go faster, when do we have to go slower in order to minimize our fuel consumption and also the CO2 impact. We did an interesting project about, in a terminal, when our units are going to be available to pick up. So we give that information, the same as a courier in the post, so our customers in logistics could actually pick up the unit and not creating a traffic congestion. And I know I'm going fast. I just want to go to the main one, but it's more about the concept of what we're working on. We're working with finance about predicting collections and trying to see when something is overdue. We are setting in our cruises what are the targets, how much we should be selling every day, and using that information to optimize how many burgers we have to cook. What is the expectation of whiskey on a day, so we need to make sure to restock. Those are all the same concept of using some machine learning, trying to understand the data, put some prediction, and we give it in action and give it back to the business. And we're using Python as a baseline. And last, we are also working on our terminals, how to optimize the flows. We have all tracks, we have tags, moving trailers, how to identify where something should be placed and how to create a smart parking problem around that. Any questions before we go to the main event tonight about any of these? Yes?
Prior to doing it with machine learning approach, what was your approach?
So why machine learning?
Yeah, no, I'm more interested in what were you doing before? Were you doing any kind of automation?
Sometimes it's not.
Decision making, or was it
but
human agents? Or?
Yeah, that's the thing. Human, probably. Someone setting the prices or setting the standard, whatever is the price for anything.
Yeah. running a logistic regression if you haven't tried it before.
Yeah, but to be honest, that's what at the end machine learning sometimes is just a simple regression, but it's a way to standardize our ways.
Then the value is just actually collecting the data. It's not doing cool models.
You can argue that, but I think setting up that scene and doing that creates value for the business.
There's nothing wrong with it being hot and cool and trendy. And
Yeah.
now you're actually doing something that's way better than not doing it. I'm just curious, what was your journey to where you are now?
Yeah. So the goal of standardization and the goal of creating efficiencies, and even if it's logistic regression, setting that scene in live and then actually create efficiency based on that. I mean, it's not always logistic regression. It gets way more complicated.
I mean, when you tell something like 20% value added, I'm interested 20% relative to what?
Imagine the baseline. Imagine like someone doing that decision every day. Yeah, that's true. Any other questions on this? Yes.
How many are you in the department?
So we have a department that is 7 data scientists. We have around 4 data engineers, if you consider people also in Turkey. We have a similar department in revenue management that is focusing more about the revenue. That's 6 people, 7. So give it or take 15. Any other questions? Super. So now to Taro, you're gonna take this one. Thank you. Hope you enjoyed.
Hi everyone, my name is Per Lundemann and I'm working in UEL's group or chapter as a data scientist. And I'm here to tell you something about a recent project that I've been working on concerning planning of hazardous cargo on board our vessels. So just a brief outline. Let's start off by just telling a little bit about what does it mean, planning of hazardous cargo, and what type of vessels are we dealing with in DFDS. Then we'll get to why is this a case for optimization. And then we'll get to the more algorithmic part. I'll describe and with a simple example of what's the principle of the constraint programming technique we're using. Then we'll get to the actual application that we've developed on for planning of hazardous cargo, and then we'll get to an outlook. Okay, so you probably already saw that on UEL's slide, and here we go again, planning of ro-ro vessels. So the first question is, what is a ro-ro vessel? Maybe most of you are familiar with container vessels. DFDS mainly has ro-ro vessels, and well, we could ask, I guess, based on previous Pydata, we could ask DALL-E to make a picture depicting a ro-ro vessel sailing in Copenhagen harbor early in the morning. And well, you can, let me just get a, well, you can actually see, I think this one is something that resembles a harbor bus, but otherwise I don't think this looks like Copenhagen, and this certainly doesn't look like one of our vessels, and I think the CEO, he would be very sad to see this dark smoke coming out of the chimney. Anyway, a ro-ro vessel, that means roll on, roll off, and that's exactly what it does. So we have a vessel like this, and all the cargo is rolled on board the ship. So here you have examples of trailers that are rolled up on board the ship, typically unmanned. So it's rolled on, off, and then it's only the trailer left. But it's also other stuff. It's equipment, like here you have an example of some coils. It could be cars, so this is not a passenger ferry, but so it's new cars that are being loaded. And machinery, something like this, and here we have something, sometimes you odd-sized are put on what we call maffies. So here you have some wood pallets that are put on top of maffies that is also rolled on board the ship. So this is sort of the game of loading all this on, and that's done by the tug drivers. And so this is a tug. This is a special kind of truck that is able to pick up all of this cargo, and then it rolls it on board the ship. And typically you have 5 to 15 tug drivers unloading and loading a ship, and it takes something on the order of 5 hours to do this whole unloading and loading. And of course, this requires careful positioning. First of all, you want to pack it as densely as possible so you can carry as much as possible. But it also requires careful positioning. If some of these trailers, for instance, are containing hazardous cargo, then you are bound by some restrictions. Maybe you're only allowed to put it on a special position. So these truck drivers, they need to be aware exactly of where they are putting the hazardous cargo. And the officers on board the ship also need to know where are they exactly put on board the ship. So that's the sort of the gist of hazardous cargo. And now we immediately dive into why is that then a problem for optimization. Mm-hmm.
So is it like a one-stop route? So everything you load, you unload the next time you ship out?
Yeah, not all of them. I don't know how much of it our routes, but many of our routes are only like A and B and back and forth. But we also have like triangular routes that involves constant circular route. Yeah. Okay, so planning of hazardous cargo, let's just sort of set the scene of what it's about. First of all, if we consider these trailer, or we can also call them units because they're not necessarily trailers, each trailer can contain multiple hazardous cargo, and I'll refer to those as packages. And try identifying this, say this one is a hazardous cargo and this one, and each of them has several hazardous packages. I've tried indicating that with these squares. And each package is then characterized by a set of features, let's call it that. One of the major features is the IMO class, and that's depicted here. So IMO class 1 tells whether it's explosive, or it could be a liquid flammable, or a gas, or a radioactive material, and so on and so forth. And so it could be that some of these packages are bound by certain restrictions. For instance, it could be that this package here, the red one, is not allowed to be near the living quarter. So that's this building here where the crew is sleeping. So maybe we would prefer to move this one up here instead. And it could also be that this one contains a marine pollutant, and typically we don't want to put that near the bulwark, so near the edge of the ship, so we'd rather put that a little further inwards on the ship. And then finally, we could also be bound by separations. So maybe the yellow one and the red one, they are not allowed to be close to each other. They need to have a certain distance between them. And also for the planning officers to have a good mental map, we don't want to scatter the hazardous cargo across the entire ship. It's better to have it sort of clustered in small groups so that they're also remembering where exactly did we put. So perhaps this would be a better way of positioning the hazardous cargo. That's sort of the principle of it. And so this brings me a little bit to the motivation. I will not go into the details, but there's a foreman on the terminal who sends a mail right now. That's how it's been previously been done to the planning officers. And the planning officer starts looking up each of these packages. What are the segregation rules and the restrictions from? They look that up in a third-party supplier called IMDG. So that's a non-profit organization that keeps track of all the regulations that are there for hazardous cargo. Once they do that, they start making like a stuff in an Excel sheet, and they'll send that back to the foreman, and they'll even print that and send that to the truck drivers. And so as a data scientist, it starts itching in your eyes, right, when you hear all these mailing, Excel sheets, and printing. But so of course this is in itself an ideal case for automizing. But let's look just on the hazardous cargo. So this thing, looking up, what's the type of features that are available there? Well, here's an example from HasCheck from IMDG for one package. This is one UNO number, 3011. By the way, there's 5,000 numbers of these, so there's like a tremendous amount of different hazardous cargo. And you can just see the amount of information here. This is stay clear of living quarters, it's heavy metals and their salts. That's where it needs to be segregated apart from. It's a flammable, but it's also a marine pollutant, and it's poisonous. So it's a lot of stuff to keep track of by the planning officers, and they are actually extremely good at it. I'm surprised about how much they actually know by heart, but it's like a complex task, and it takes time. And so the value is obviously it increases safety, but it also saves time from our part. And going back to this thing about time saved means that they can sail slower and thereby reduce CO2 emission. And maybe that could then address this awful Dali picture of black smoke coming out of the chimney. So let's go into the algorithm that we've used for planning of hazardous cargo, and that's called constraint programming. And so why am I showing an image of penguins? First of all, I was in doubt what image fits with constraint programming. And so penguins, they're just cute. But also there's something about this thing, right? This small baby penguin apparently they need to go on a line, right? So they're constrained to move on a line. And this one cannot move ahead of his mother or father, because then he'll probably get lost or don't know where to go to. And this one better keep up with the last one, otherwise it will also get lost. So there's a little bit of algorithm in this way of this pattern that you see there. And so constraint programming is all about finding feasible solutions, and you utilize the imposed constraint to reduce your search space. So it's an algorithm that's good for binary variables, and it's an algorithm that allows you to introduce nonlinearities. Maybe a lot of you have heard about mixed integer programming, but that's linear by definition. Never spoil the chance of showing a beautiful image of the universe, and I couldn't help myself, but so these problems that we are trying to attack, it's problems where sheer brute force is absolutely out of the questions. If you have 200 units, you end up with a gazillion combinations. That's simply not possible. So let's try and have a toy example. And once again, I couldn't help myself asking Dali, a toy example of hazardous cargo. So that's apparently this thing. You have some balls, and then you have something that looks a little dodgy, hazardous at least. So let's just take a 3x3 grid, saying that those illustrate the positions of our trailers, and we are dealing with 3 different trailers, a circle and a square and a triangle, and those are hazardous, and they are imposed by some constraints. So here I impose the constraint that the circle and the square needs to have a distance of larger than 2. And here I'm thinking of the L1 distance, so the taxi driver distance. The square and the triangle needs to have a distance also bigger than 2, and this triangle and the circle needs to have a distance bigger than 1. Okay, so how do we go about? So it's this thing about eliminating the search space. So let's just start by picking one of them. Let's take the circle, and then I can put it somewhere, and why not put it right in the center? And so as soon as I put it in the center, I can look at my constraint for the circle and the square, and then say, well, it needs to be at least a distance of 2, and so I already see now I've eliminated all other spaces for my square. So obviously this is not a possibility, so I'll backtrace, I'll go back again and try a new solution. So I can put it here, and then I'll identify all the spaces that are not possible to move my square onto, and so I'm left with these 2, and why not just pick randomly one of them, and I can put it here. And now I'm at a state where I can start planning for the triangle. And for the triangle, it needs to have a distance of 2 to the square, so I'm only left with these 2 spaces. But if I put my triangle here, it will have a distance of 1, so it's not bigger than 1. So already there I can see this is not a solution. I'll need to backtrace, go back again, and try one of the other ones. Okay, so when I put my square there, then I'm left with these blocked positions, and I'm the only one available is this one, and so this one does exactly fulfill the condition that the distance is bigger than 1, so I can put my square there. And hooray, I've found a solution to my problem. Of course, this is a 3x3 matrix, but the principle of eliminating your search space once the problem gets bigger and bigger, there you really reap the benefits of this type of problem. Now, so these were constraints, but I could also have some preferences. So maybe this is a feasible solution, as you call it, but there could be that I would prefer perhaps having my trailers as far away from the living quarters as possible. So say this is the living quarter, and well, I could probably easily see that I could rotate this 90 degrees, and then I could get a solution like this, and this would be a better solution because 2 of my trailers are now the furthest away from my living quarter as possible. That's the gist of it. You have these constraints, and you can also impose some preferences such that you can weed out among a lot of different feasible solutions. You can choose which are the best ones. So what we've used for our problem, we've used a package made by Google called OrTools. So they offer several different optimizer algorithms. So they have a linear optimizer and a mixed integer programming optimizer, and then a constraint programming optimizer. And it's available for Python, C++, and Java and C#, but why not try and make an example in Java since this is in Python since this is Pydata. One thing I'd mention about this package is that I think it is a really good page that they have with some really neat examples, and they explain the problems, and they also explain the math in the problems and how you can solve it using their package. So I think for those new to these kind of problems, I think it's an excellent tutorial page that they have, where at least I learned a lot from it. Okay, so let's just try and go through a little bit of some simple code that tries to attack this 3x3 matrix problem with our trailers. And by the way, it's all uploaded to GitHub on this address, so if you want to have a better look at it, then please go and have a look there. So we start by creating an object from this package, CP model. We create a constraint programming model object, and then I define some input variables. I defined my grid, the number of rows and the number of columns, and then I define my names. So I have a circle, square, and triangle. And then I create some structure that allows me to find my variables, but I essentially create all of these variables that are Boolean variables. These are my discrete variables that I'm to optimize. And I do that for each name, I loop over each row and column and create a Boolean variable. So it's like either it's occupied or not. And for those who prefer the math notation, I think this looks much more simple. You have a variable x, and for each name and subindex I and j indicating the row and column, it can be either 0 or 1. Okay, so now we've set up the problem. That's sort of the initial thing. Now we can set up the constraints. And so without thinking about anything about hazardous cargo, and then we have these segregation, but this thing about positioning them on a grid, what constraints could you think of that we at least need to have before I start thinking about separation? Yeah.
They have to be integer valued, or I mean, depends what you mean by constraint. You mean just
Yeah.
the domain?
Maybe that's a little fuzzy. Yeah. So it's already I've already defined them as Boolean variables, and hence they can only be. But maybe I'll just show you, and then you can see. Yeah, of course. So first thing is that I can only place my trailer once, and exactly once, right? In this game. That's a constraint that I need to add. It sounds like a dull constraint, but I need to add that. And I do that by looping for each of my names. I loop over them, and then I loop over all positions for that given name, and then I impose the constraint. I do that by this model add method. I say that for the sum of those needs to be equal 1. So for any of my trailers, the circle, square, or triangle, it needs to be somewhere. And in math, this is also looks a little bit more simple, maybe, this notation. A second rather dull constraint that one may need to implement is that I can also only put one trailer per position. And so in this case, I loop over each position, each row, and each column, and then I sum over all my names for that corresponding position and say that the sum of that needs to be smaller than 2. So there can be 0 or 1, but not 2 in one given position. Yeah.
So if they're booleans, right? I mean, when you're summing them,
Yeah.
you're taking an OR operation, right?
Yeah.
So,
But I guess that's how.
so strictly speaking, say you put two things on top of one another, then that constraint doesn't really add up, does it? Because then things could, couldn't you have things like cancelling out, for instance? And I mean, if you're actually doing Boolean logic, then writing it in terms of sums, isn't that a bit dangerous?
So the sum of booleans, I think also actually in Python, but also in all tools, means that then you start treating them as 0 or 1s.
Yeah, but the sum of booleans, you're a finite field of order 2, right?
Yeah.
The product corresponds to and,
Yeah. So
sum corresponds to OR.
yeah, it's not logical operations in that sense.
This summation
It's
sign
actually
is sum
it's
over
actually
that
a
field.
sum. Yeah.
So it's a sum over a finite field of order 2 or a sum over integers?
It's a sum over integers at least. Yeah.
Then you can't call them booleans. As a mathematician, I forbid it.
That's fine. It's how it works actually also in base Python. If you have if you sum two, if you add the constraint, or if you apply a summation between two booleans, then they will be treated as integers. Anyway, that brings me now to the little bit more exotic thing, the segregation part. So we have these requirements, and let's just take the circle and the square and remember that the distance between those needed to be bigger than 2. And so how I do that is that now I take for each position of my circle and for each position of my square, I create a new variable. And this is the sort of the little fuzzy thing about it. So when I say anything about a distance, I need to treat it as a variable within the OR-tools framework. So I create a new variable called the distance variable. That's an integer variable. I'm allowed to sum those. And that goes from 0 to 4, because it's the L1 distance. It's a 3 by 3 matrix, so the biggest distance I can have in this 3 by 3 grid is 4. And now I impose this, I sort of lock it onto the value of my distance that is calculated. This is just a number I calculate. What is the distance between position 1 and 2? And so I say this one, that's a constraint. I add the constraint that this one needs to be the same. And now I'm finally ready to set up the actual constraint, the constraint that the distance variable needs to be bigger than 2. And so I add the constraint, the distance variable needs to be bigger than 2, but I only enforce it if the variable 1 and 2 are both there. So meaning that variable 1 is true and variable 2 is true. So implicitly in this list, there's an and between them. So in math notation, this would be something like this. My variable for the circle, if that's 1, and my variable for the square is also 1, that implies that the distance should be bigger than 2. Okay, so now we are ready to look at the solution. So now I've set it up, and then I will just call the method called solve, and it will spit out the solutions. So how many solutions do you think there would be for this problem?
Are we counting with or without symmetries?
Did I impose any constraints that...
Fair enough. 2.
We didn't put the preference in there.
So there's actually 16. There's a lot of reflection, rotation, and symmetries.
Constraint anymore of distance to the side.
So the only constraints I've put now is that I can put it once,
Sorry,
and I can't put them on top of each other, and it needs to obey the distance requirement. And here we can recover the thing that we found by ourselves going through the algorithm. Okay, so how do we then impose this thing about adding preferences? So now I've only added constraints. That's the thing that needs to be fulfilled. But I can also add some preferences. So maybe some solutions I prefer more than others. So remember, this was the living quarter, and I prefer to have them as far away from possible, and I could do that by just rotating. How do I do that? Well, I define a loss term, and I do that by summing over each of my variables. And then for each of those variables, I find what is the position of that variable to the edge of my grid. So for instance, this one, that would be this distance. And for this one, that would be from here to here distance. And then I multiply. Now I'm multiplying with a Boolean. Think of it as an integer. Now I'm multiplying with my variable. So if my variable is unoccupied, it would be 0, and then it doesn't contribute to my loss sum terms. If it is occupied, then it's 1, and then it contributes to my loss term. That's the gist of it. And then I tell my model that indeed you should minimize the loss. So here I multiply by a -1 in order to make it a loss. But you can also make it a score, and you can call maximize instead if you want. That's the way you implement preferences in all tools. And once you've done that, then you can call it again, and then it will come up with these two solutions. This one being the one that we just saw if you rotated it. And so here it also tells us the score, it's -7. So this is the best solution. And we can also see, but there are more solutions with a score of -1. I could reflect this one, right? Putting the blue where the square is and the square, the circle where the triangle is and where the triangle is and where the circle is. But it will only give out the first one with that given score, and then it will stop, and then we'll hand out what's the next best solution. And then there it will also just give you the first solution. Okay, so that was the sort of the sandbox model of something that resembles a little bit of allocation of hazardous cargo. Once you get into a more realistic scenario, you'd want to impose some max times that you allow it to calculate, because typically you would not be able to find the optimal solution once you run into a realistic scenario. So you impose some bound on how long is it allowed to calculate, and then we'll just hand you out the best solution it's found so far. You can also set the number of threads for doing the search. And you can also tell it that I don't want you to look through, hand me out a lot of different solutions. Just give me the best one. That's also what we are using for our example. That leads me to what does it actually take for our application to make it sort of useful. And I'll just highlight a few of the extra things that we've implemented. So constraints, first of all, you need to be able to block positions. It could be that there's some repair on board the ship that you need to add. It could also be that it's already occupied by non-hazardous cargo. And it could also be that there are just spots on board the vessel, for instance, a ramp where you don't allow hazardous cargo, the ramp that connects the decks. You don't allow hazardous cargo on those. Then there are unit-specific restrictions. Maybe some needs to be near electrical plugs. Some are not allowed to be near living quarter. Some needs to be on ventilated decks, and actually some are not allowed to be on ventilated decks. And then a more practical constraint is that we also need to block a unit from being planned on board the ship if it's not ready on key. So sometimes the unit shows up late, or sometimes their customs paper are not ready, and then we shouldn't hand out the plan to the tug drivers so that they start putting it on board the ship. For preferences, there was these things that are not hard constraints, but more a preference. So there was this thing about being away from the bulwark of the ship for marine pollutant. And there was this thing about clustering. So if we, in order to have a better mental map for the tug drivers as well as the planning officers, maybe this is an okay solution, but we would prefer a solution something like this, where we've clustered those that can go together in one corner and maybe put as far away another cluster away from this unit. That's another preference that we add to this type of solution. And then a little bit set up for what we have been working on. So we are consuming some Kafka events that is put into a database, and when an optimization is called, it's fed into this third-party service, this IMDG service that tells us what are the regulations and what are the exact segregation terms for this cargo. And we put that into an optimizer and formulate it as constraints. And we also pull out a structure that we've built that resembles the ship, so we know what positions are there, what decks are there, and what restrictions do we have on board this vessel. And then ideally it's fed to an engine on the terminal, so they use a terminal planner tool for doing this thing. This is still sort of in a pilot phase, so we've so far built a Streamlit front end, but the end goal is that this serves as an engine for some other tool that they are using on the terminal. Okay, so this brings me to an outlook. Yes.
So you mentioned non-linearities.
Yeah.
Are they in the cluster distances in there?
Yeah, that's one of them. Yeah. So as soon as you start doing some clustering, it's something with pairs constantly, right? So it's something with the product of these booleans, and then you add a score to that. Yeah. Yeah.
How do you validate the model and the quality of the model?
Yeah, so I have been iterating back and forth a lot with people on the terminal in Rotterdam and planning officers on board a lot of vessels. But essentially, they go through and they run it, and in the initial phase, they sort of stumble upon, well, this is not allowed, this is because this and that, and and this cannot be done. And as we had weeded out all these constraints, then eventually it started becoming their preferences. Well, I know it's okay, but we usually actually do this and that. So that's the way. So the constraints, that's something you can sort of handle, but the preferences, that's more. There's not a score or anything. Well, there are scores, but as soon as I redefine my model, the scores are just a new. No, it's not normalized. Yeah.
So in case it aborts because of the time limit, you said max time 100 seconds or something.
Yeah, yeah.
So if it aborts like that, is there some sort of theory like duality in linear mixed-engineer programming that tells you what the optimality gap is? You get something similar out of OR tools for constraint programs?
I don't know whether I think it's extremely hard comparing different solutions, and it's so subjective.
That's why I'm asking.
Yeah.
Within the formulation you have now, which you might change tomorrow based on feedback.
Yeah.
But just do you know if you spent your time budget in seconds?
Yeah.
How far away from optimal you are?
Yeah. No, that you don't. I don't think you can know that.
Not without knowing a bit more about the loss function.
For this problem class.
Yeah. I mean, for instance, right, if it's linear, you have duality theorems.
Okay.
If you can be bounded by linear things, you can do duality theorems with caveats. Okay. And I don't know, I'm sure there's stuff for polynomial bounds as well.
You had a question up there?
What about politics, user adoption, and all the other things? Like, did you have a lot of hurdles to get that out?
Oh yeah, I could do an entire talk. I could do yet another talk on that subject. Yeah, there's a lot of. There are also very practical issues. For instance, when we started out doing this, we had a collaboration with one of our ships, and one of the first problems is that we made like a front page that was available in a browser, but they didn't have any internet connectivity. So that's when they were out sailing, and typically they carried out this task when they were out in the middle of the ocean. So that's one problem. But there's also very much on, well, today we are only this many tug drivers, so typically then we would prefer to put them on this deck, but otherwise we would always prefer to have the Hazardous on this deck. There's a lot of these things that also, there's also some change management in this process. Yeah. Yeah.
Do you have standard set of constraints and preferences, or does it change dynamically? And if it changes, how often does it change?
The constraints?
And preferences, yeah.
I don't think they change. So we've tried implementing it such that most of the preferences, they are associated with the vessel. And so we built like in in a JSON format a structure of the vessel that indicates both something about their preferences in terms of scoring. Do we prefer to put stuff on the weather deck or on the lower deck? Or do we prefer to put them forward or backwards, or these type of things? So we tried layering into like a structure of the vessel that at some point should be some planning officers. They are the only ones who are allowed to go in and do changes to this, because it's essentially their preferences that they can apply. The constraints, I haven't changed them for a long time. Yeah, you are up there, yeah. Yeah, yes.
What if you make your preferences into constraints? Does that, I mean, yeah, you can't measure how well you're doing. You can't measure, you don't have a
Yeah, yeah. So one of the problems with the preferences is that you could run into, then there exists no solution for this problem. If they have a preference of, well, we don't want anything within 12 meters of the living quarter, maybe that's simply not possible. So that's why you need to implement these things. Whenever it is only a preference, you need to implement it as a preference. Yes, I don't know. Maybe you in the middle or the...
So you took this book of 5,000 hazardous different kind of materials and you translated all of them into constraints by hand? Or how did you approach this?
I didn't get that with the 5,000.
You said at the beginning that there's this document with about 5,000 different hazardous materials.
Oh, yes, yeah. No,
So
that's
is that one category, or you took each one of them and coded that into constraints?
yeah, no. So we are asking this hashtag, this non-profit organization, we are asking, okay, we have this package, what are the features of that one? And then you will look into, then there's a declaration that comes with each ship that tells something about where are stuff allowed to be put relative to all of these features. So those were, it's mainly based on the feedback we get from IMDG. Then we can implement those as constraints, but it's not thought to be as one constraint per one of these 5,000. Yeah. Yes.
What kind of equipment you need to run this, and how many machines, how long does it take?
Yeah, so this is run on a Kubernetes pod with 16 gigabytes of RAM and 4 or 8 cores or something like that. So it's nothing. Yeah, it's laptop size. You were up there?
Yes, so you mentioned that you discover preferences as you go along and talk to users. Is it your impression that the preferences have been exhausted at this point? Like, do the users trust the model? Do they think they get the same quality that they did before when they did it manually, just faster? Or do they feel like they get something that looks kind of weird and it's not really very nice?
Yeah. No, I think we've gotten to the point where they sort of, some of them told me at least that I couldn't have done it any better. So I think in that sense, I think we're more facing some practical issues about right now we've made an app and they're essentially doing all the planning in this terminal app, and so they're having to, so we're waiting for the resources for being able to integrate it into their terminal tools. Yeah. Yes?
Are you placing all containers, only the hazardous one? And if you're placing all, are you also doing weight distribution, or is that left to the texture?
That's an excellent question that was just coming up here. So the plan is that we should expand it at some point to involve all cargo. And of course, there's this thing about you can also impose that you want to balance the weight on, so you can reduce the amount of ballast, or you can balance the weight so you can reduce the amount of ballast. But there's also just this thing that there's actually an interconnection between hazardous cargo and non-hazardous cargo. For instance, a reefer container produces heat, and some of the hazardous cargo is not allowed to be put anywhere near a reefer container. So eventually we would need to do that. Yeah, I just sketched here, but maybe I think I prefer to keep on doing some of these questions. But we're facing a lot of these, I'd say, classical optimization tasks in DFDS that are ripe for being implemented. Yes.
Yes. Did you try or consider different optimization packages?
Yeah.
CVX or Kymo? Or
No, I haven't. Yeah. Yeah. Yeah.
On that note, do you know how all tools performs on mixed integer relative to Groby or Suplex and so on?
I don't know with mixed integer linear programming how they perform to others. So we had this need of implementing some nonlinearity. So we went for constraint program, but I know that constraint program they're exceedingly strong. So there are like these competitions within this type, and they win for the last 8 years. They won the gold medal.
So what's it cost?
Sorry?
So what does it cost to use?
It's free. Yeah, it's open source.
Open source and free?
Yeah. Yes.
At the beginning, you said that actually the units are not all of equal size, which would imply that you actually have another optimization problem there, and it's not just a matrix where you place positions.
Yeah. So it's not really a problem, but if we had like a if a big proportion of the cargo started having odd sizes, then it would start being a problem. But all hazardous cargo are typically carried in these standard sizes. That's that way I can sort of treat it as a positioning of my as these slots, these grid on board the ship. But you're right. As soon as if it was like completely floating, this positioning, and it was in width, and then it would be much harder to solve. But I've seen some actually doing it, but maybe not with as many constraints as this. Yeah. Yes.
This might be a stupid question, but it seems that you are placing them like sequentially. So some arrive and then they're placed, and then others arrive and then they're placed.
Yeah. So
So you need feedback from where they're placed on the ship. Do they put that back into the system?
yes, they do. So, but that's also not valid for all terminals. So some of the terminals, they don't actually have access to at the moment of where exactly was it put, but the ones that we're testing out, they feed back into the data system where were things put, and that's then imposed as a constraint for the next iteration. But it's typically something that we plan like 80% of it, and then you have 20% left that are still not ready, that then are being planned for iteratively. Okay, if there are no more questions, I just end with some acknowledgement. Martin Morset has been a tremendous help. Unfortunately, he's not with us in DFDS any longer for helping me out on all architectural work and also taught me a lot of tricks within data engineering and data architecture and also programming in Python. Jorik and Julian, I visited them in Rotterdam, and they also gave some very good input from what does it take to make it practical. We have the planning officers on board some of our ship, and I think Uriel has been helping me a lot on these phases of a POC and a pilot and the arts of project management. And then I think also our data science chapter, we've been given very good reviews and valuable insights in our pull requests. Yes, I'm going to the questions, but we've already had a lot of questions, so maybe we should just have a chat afterwards. You're welcome to come and ask me if people are up for it, we can also keep on having a chat here. I'm fine with that.
I think we have a few questions if there are still some more in the audience, and then
Okay, yeah.
Your toy model, do you have a slightly more complex example, or could you elaborate on how what you're doing isn't just backtracking? Like, I mean, most people who've done a computer science algorithms class will probably have learned backtracking at some point or been asked to implement it.
Yeah.
So, I mean, if we're doing this kind of optimization, I mean, there has to be something you need. If you actually need to implement a pretty sophisticated library developed by guys at Google, I mean, there has to be something more happening under the hood, right?
I'm
What's
sure.
the thing happening under the hood?
I would not be able to tell you. So I have to be honest. But so what I. But I think the art of this thing is not the finding the feasible solution. If you only have constraints, then there is something about this thing when I move from one. Which one should I take then? Should I take this one or that one? And if you don't have any scoring, then you don't have anything. But the heuristics comes whenever you have scoring, and how, if you look at this as a tree, which path should I? What has the biggest probability of offering a better score?
But I mean, for instance, if you're doing backtracking, right,
Mm-hmm.
and you are being, I don't know, before the fact, you don't necessarily know, are my constraints incompatible, right? And if you're doing naive backtracking and just ruling out anything that rules out a constraint, that means you end up trying to enumerate every single solution only to find out it doesn't work.
But that's not how it's.
If you have incompatible constraints and start taking this approach, it's going to be insanely slow, only to in the end tell you, sorry, can't do it.
I think that's the art in all these solver
Of course it is,
processes.
but I want to know how they do it.
Yeah.
In open source.
Branch and bound. I think you need to get hired there to learn it.
given that I don't think we can get the answer from Per today,
No.
I'll say thank you very much to our speaker. For those of you who do want to ask more questions, I'm sure you'll be hanging around for a little bit.
Yeah.
We still have a bunch of drinks outside. No more pizza for once. We get kicked out at, what was it, Joel? Oh, at some point we get kicked out.
Try not to do it.
Yeah, I'll meet you at the bar.